Being late, everyone, but we are now live.
Welcome, everyone, to the virtual 2020 AOCS Annual Meeting and Expo live stream. I'm Janet Brown, AOCS Director of Membership. I have here today with me Alan Paine, AOCS member. He's going to provide an overview of oil contaminants. Let me tell you about Alan. Alan was born in England and studied chemical engineering at the University of Surrey in Guildford. In 1984, he joined the Rosedowns Company, which is now a part of the Desmet Ballestra group. In his career, Alan has taken various roles, mainly associated with vegetable oil refining, including 5 years working for Desmet in their Atlanta, Georgia office. Today, he lives back in England and has recently retired from working as a global technical support on behalf of Desmet Ballestra's office in Brussels, Belgium. He is a regular contributor to Inform Connect. Away from work, Alan's interests include running, amateur theater, music, and writing. Together with a group of 8 other writers, he has brought out a collection of linked science fiction stories available online as an ebook or paper book. So the aim of today's presentation is to give you a review of various types of contaminants in edible oil, how they came to be there, and how they can be removed or avoided. Alan will address your questions throughout the live stream, and we look forward to your conversations and your contributions. So thank you so much for joining us. With that, I'll turn it over to you, Alan.
Thanks so much, Janet. Can you see me on the screen? Oh, yes.
Yes, we can.
Yes, we can. Okay. Right now, what we have here is some oil. This is from a well-known UK supermarket. It says it's made from 100% sunflower seeds, but we can rest assured that all of the contaminants, or that many of the contaminants we're likely to find, are going to be present in this oil. Now I'll just try a little bit here, and it seems to be okay, but almost certainly that contains some trans isomers. It contains 3-MCPDs, glycidyl esters, probably some traces of pesticides, and a number of other things which I'll pull up on this list that we can see now. So no, oh, just a minute. I've jumped in here too far. So what we have here is a list of oil contaminants, most of which will be found in this sample that I have here. Now, this is not an exhaustive list, and if we weren't careful, almost anything could end up in our oil. And I'm not going to cover the process of adulteration, which is the practice of secretly blending one type of oil with another in order to cut costs. Some of these substances are classed as persistent organic pollutants, or POPs, which can remain in the environment for a very long time. Phthalates are used as plasticizers in plastics and also found in a wide range of other products. Phthalates are said to be so widespread in the environment that even oil from which they removed can quickly pick it up again. And apparently there's even some floating around in this room which will quickly enter the oil that I've just been waving in front of you. Polychlorinated biphenyls, or PCBs, contain 2 linked benzene rings which can have chlorine or hydrogen atoms attached in any one of 10 positions, making hundreds of potential combinations. They used to be used widely as heat transfer media, especially in electrical equipment, and were even used in the edible oil industry, even though they're highly toxic. PCBs leaking from oil into oil from heating pipes in Japan in 1968 and again in Taiwan in 1979 are reported to have killed many people. The manufacture of PCBs was banned in the United States in 1977, and an international treaty in 1986 eventually led to a worldwide ban. But even today, PCBs persist in the environment. They take years to disappear, and leaks from old equipment and illegal disposal continue to make up for what is disappearing. PCBs are accidentally or deliberately released into the environment, where some of it ends up in the sea. But the concentration is extremely small, but it's concentrated by sea creatures. Some fish eat many times their body weight of tiny organisms called plankton. A lot of the PCBs in the plankton remains in the fish, so that the concentration in their bodies is much higher than it was in the plankton. If these fish are then eaten by other fish, then the concentration becomes so high that by the time people catch and eat them, the levels present could be harmful. Dioxins are a class of compounds that are formed in various ways, either artificially or by nature. And you can see here industrial pollution, volcanoes, barbecues, and all sorts of other processes. And they're concentrated in the food chain in the same way as PCBs. It's common to bleach fish oil with activated carbon and then deodorize it to remove dioxins, PCBs, and other impurities by a combination of absorption and evaporation. Sometimes the oil produced in this way is used as a human dietary supplement, and sometimes it's used in fish farms to feed salmon. Consequently, farm salmon may contain less contamination than wild ones. These types of contamination are usually very low in vegetable oil, but dioxins and PCBs are very pervasive in the environment. Polyaromatic hydrocarbons are a particular problem in coconut oil because it's common to dry the coconut meat to make copra over fires fueled by coconut husks. And coconut is particularly vulnerable to this, but it's not entirely, other types of oil aren't entirely immune from contamination during drying. The smoke that comes in contact with the copra contaminates it with PAHs and dioxins. Now, of course, it's sometimes done in more industrial looking equipment than we see here, but traditional methods are still being used. And this picture was taken, I think in the 21st century. Polyaromatic hydrocarbons are made up of interlocking benzene rings. PAHs are often divided into light and heavy. Relatively low molecular weight ones, such as naphthalene, can be removed by stripping in a deodorizer, but the heavier ones, such as benzo-A-pyrene, are much harder to remove in this way. It's common to see coconut oil being treated with activated carbon, often as a part of the bleaching process, to help remove dioxins and PAHs, in addition to what can be stripped in the deodorizer. And I said before that coconut isn't uniquely susceptible to this problem, but and it is possible to find some of these contaminants in other oils as well, but nothing like the same extent as you find in coconut oil. Here are some results from a coconut oil refinery. The polyaromatic hydrocarbons have been reduced by a factor of 6 by a combination of bleaching with activated carbon and deodorization. But the distillate contains 37 times the level of PAHs that there were in the crude oil. There are a very large number of PAHs, and at least 15 of them are considered as especially hazardous. And it's difficult, of course, to analyze from 15 or more compounds. So it's common to analyze for only 2, 4, or 8, as shown here. And PAH4, which we can see here, which is the sum of benzo-A-pyrene, chrysene, benz-A-anthracene, benzo and benzo-B-fluoranthracene. This is the most commonly considered one. And PAH4 is the basis of the regulations that are current in the EU. Pesticides can also become concentrated in distillate in the same way as PAHs. Dichlorvos, lindane, and malathion are some common ones. Malathion, for example, is a solid at ambient conditions and has very little vapor pressure. but its vapor pressure rises rapidly with temperature and it boils at 156 degrees Celsius. Now you compare that with oleic acid, which is also removed from oils during deodorization, which has a boiling point of 360 degrees Celsius. So the pesticide is much more volatile, much more easily removed from the oil than the fatty acid. Other common pesticides are also much more volatile than fatty acids, making them easy to remove from the oil and resulting in a distillate that has a much higher concentration of pesticide than the undeodorized oil. So if you want to use any part of a distillate in food or in a dietary supplement, you have to be careful about the levels of pesticide and other volatile contaminants present. The exception to all of this are the synthetic pyrethroids, such as cypermethrin and tetramethrin. They are not easily removed by deodorization, but have relatively low mammalian toxicity, so that you are not likely to